I'm Eliza and I am the water technician for Friends of the Dart, and this video is going to explain how to interpret the graphs that we're publishing on our website showing the data that we've collected at each of our sampling sites. So Friends of the Dart are a not-for-profit organisation advocating for the health of the river. We're working to reduce pollution, improve biodiversity and empower communities from source to sea. Our Phase 3 monitoring programme began in 2025 and we're sampling 31 sites monthly under both wet and dry weather conditions. This just means whether or not it's rained in the days leading up to the sample, and sampling under both conditions helps us understand how pollution levels are changing in response to wet weather events. We're using Petri films, as shown in this image on the right, to measure E. coli concentrations. E. coli are a key fecal indicator organism whose concentrations in water correlate very closely with fecal pollution levels. So understanding the concentrations of E. coli in the water helps us understand the levels of fecal pollution within the water. So to explain our graphs, once we've completed a sampling round, we input our data into the raw spreadsheet, which can also be found on our website, and this generates graphs for each of the sampling sites. So each graph that you find will be the most up-to-date data that we have at each sampling site. In the top left of each graph, you'll find the site name. And if you're interested in where the sites sit on a map, have a look at our Phase 3 monitoring map, where all of the sites are pinned. And if you click on each of the red pins, it will bring up the site name, as well as the coordinates of the site. On the x-axis of each plot, you'll find the date that the sample was collected, which helps understand how pollution is changing over time. So for example, this sample here was collected in early March, this one in early April, and so on. On the y-axis, you have the E. coli concentration in colony-forming units per 100 millilitres. This is just the standard measure of concentration for E. coli. On the right, you'll find the key which explains the different coloured data points. So all of the black data points represent samples that were collected under dry weather conditions, and all of the blue data points are samples that were collected under wet weather conditions. And each graph will have a dashed horizontal line. This represents the threshold for excellent bathing water quality, as defined by DEFRA and as used by the Environment Agency to categorise bathing sites. So Dartington Beach is a non-tidal site, which means that the threshold for excellent bathing water quality is at 500 colony-forming units per 100 millilitres. This means that all of the data points that sit below this line are considered excellent, so the sample taken on that day at that site was excellent in terms of water quality. This graph represents the data that we've collected at Bow Creek. Bow Creek is one of our tidal sites, so as you can see, the dashed horizontal line sits at 250 colony-forming units instead of 500. This is because the threshold for excellent bathing water quality is different for tidal sites when compared to non-tidal sites. The tidal sites that we currently monitor are Bow Creek, Steamer Quay in Totnes, Stoke Gabriel, Dittisham and Wharfleet Creek in Dartmouth. We're currently working on a more easily accessible way of presenting our data to the community, and we'd like to bring in data from other organisations as well. So these plots are what we'll use in the meantime to visually represent our data, but do watch this space as we will be updating on our website to create an easier system for people to have a look at our data. But I hope that helps explain how to interpret the graphs on our website, and if you do have any further questions, please just send me an email at eliza@friendsofthedart.org. Thanks.